Okay. Hi, everyone. This is Dr. Jessica Logan, and I am your instructor for the ESQREM 7651 course, the regression analysis class. And so I just sent around information um, about the syllabus, and then information also about the data set that you'll need for class. And I just wanted to really quickly record a little bit of information for you about what your data set should look like, because I think that'll be really useful for some of you as you're preparing or looking for a data set or preparing your data set to use. So I'm going to share my screen really quickly and then talk to you about quantitative data analysis. Uh, in a second, I will. First, I want to talk about how, one of the requirements for this class is that you have had information about um, knowing what a mean is, what a standard deviation is, how to calculate whether there's a difference between two groups, and understanding what a correlation is. So many of you are understanding or are familiar with the concept of a correlation sort of generally, and are used to looking at maybe a scatter plot of points. So what we're going to talk about today when we're looking at a data set, what I realized is that you may not have the background or information about what the data set looks like that sort of underlines or underpins those relationships that you're looking at. So I'm going to show you a little bit about what a data set should look like. Okay, you are seeing the wrong screen. So let me try that again. Okay. Maybe you're seeing the right screen now. We'll see. So it says in this thing here, we say that you need a data set, and here are the requirements for the data set. So just a context for the date, it is due September 14th, the first assignment with this data set that you'll be looking at. So that's why I wanted to make sure that you had all the information you needed to start looking for this data now. This data set now. Data are plural. Okay, so I want you, first of all, to be analyzing a data set that's within your area of expertise. And I want you doing this because I want you thinking about what the kinds of questions that are really interesting to you, rather than a random question that I make up from a random data set. Because, for example, here is a question that I have used in previous coursework. Something like, how often do you watch TV? And here's a 5-category response for how often you watch TV. And how is that related to how many movies you've seen, or how much coffee you drink? Or, well, this is from another university, so how does Tallahassee have good food? I imagine many of you don't know that because you have not ever been to Tallahassee. But so when you look at, I imagine many of you have filled out a survey like this. So what I want to show you is how you go from a survey like this to actual data that's usable. So we're going to take this, and what I have done with this survey is turned it into some data. So here, right here at the end, this is that coffee question that I asked on the survey. I have questions of, what was it? How many cups of coffee do you drink every day? And it looks like I've coded them from 1, 2, 3, or 4, depending on which one, or 1 through 5, depending on which one people checked. So there they are. And so the key point here that I wanted to make is that we've taken this idea of a question that you've seen on a survey like this, and it gets turned into an actual number represented here in a data set. Now, I have this in SPSS, which is a program that you can use to analyze your data this year. But you can also look at it in Excel or anything else that you keep spreadsheets in. What's that like? Sheets, Google Sheets, maybe? Anyway, all right, so my example here, what I want you to notice is that each row represents an individual person who has responded to these data, to this survey. Each row is. And every column is a different question that they have asked, that we've asked them to answer. So I have my data arranged here in rows and columns. So this right here, coffee number 4, one person responded that they drink 2 or more cups a day. And here's a person and they responded that they don't drink coffee. And so that's how this aligns and sort of lines up. Let me show you what this looks like in Excel with a different data set. This is a data set that we're actually going to use a lot this year, maybe, depending on, you never know how things are going to go, especially during a global pandemic. But this is, believe it or not, this is a data set about cat personality traits. And yes, you heard me right, that is personality traits of cats. So I have here an ID representing each cat, and this is a very real data set. I pulled it from the internet, and it really exists. And there are people who study the personalities of cats. So you can study anything. All right, so this is they've rated these cats on a scale of like 1 to 7 in terms of how vigilant they are, how stable they are, how bold they are. And so in this case, you'll see that that survey, I don't see the survey, but I know that there's a survey that's been turned into these particular answers here for each individual cat. Now, the reason that I brought this example up was to show you that, again, I still have the top row here is the name of the variable. And down this way, I have ID numbers. So just an individual response or representation of who's who and which response goes with which person or cat in this instance. And then each cell has one number in it, but it represents one characteristic. So this is cat 1's personality trait on vigilance. So that's the first key point. Because when you think about a correlation coefficient, a correlation is each point represents how two things are related. So for example, you might have a point here would be an XY coordinate of 6, 5. So that would be 1 point on your whole scatter plot, a 6, 5. And then this one would be a 7, 3. And then if you plot all of these, you end up with something that looks like a scatter plot. Okay, so the other reason I brought this up is to show you 2 more things. First is that maybe your data looks something like this, where you have big gaps in your spreadsheet. There's nothing there. There's a lot of people who've just sort of skipped items and answers. And that's okay. For this, what we're doing in this class, it's totally fine if you have missing data. We may not get to talk about missing data very much in this class this year, but because I just don't know how it's going to go. But it's totally fine to have missing data within your data sets. The second reason is because I want to talk about a sum score or an average score. So sometimes, maybe we're interested in how vigilant cats are or how stable cats are, but we also might be interested in sort of a larger construct that's represented by a manifestation on individual items. So for example, it could be that you want to, if you think that cats are particularly excitable, I don't know how personality traits work. This is a bad example. Let me try again. If I have something like here, I've got watching TV and I've got how many movies you've seen in the past month. Now, individually, those might be interesting, but it also might be more interesting to add them. Okay, but here's the thing. Notice that these 2 things I was just talking about adding together, if I added together this one, every day I'm a TV junkie, with this one, this first response, 0 sad but true, that's not giving me a good indicator of how many movies we've seen in the past month. It's actually going to, they'll counteract each other. What I would want to do instead is pay attention to that when I'm adding things together. So you want to make sure that the things that you're adding together or summing together are scaled in the same way. Because if they're not, then you're not going to get a really good representation of what's really underlying these two specific variables. Okay, and let's look at one more data set. So I'm going to share with you one more data set because it gives another good example of a different type of indicator that you can, or not indicator, but different responder that you can use. So in this case, I have a data set of schools, universities, who are named by university. So this particular data set is one that I pulled from online somewhere, a university data gathering website. So within this data set, each it's not a responder because Auburn University is not a responding possible entity, but it's information about Auburn University. So this is Auburn's graduation rate. I think it must mean 2016 graduation rate. The underrepresented minority graduation rate. So it's got some information about SAT scores and things like that on average for the particular school. And so you can see that you can get information not just about people who have responded to individual surveys, but also about individual schools. But even with individual universities here, I still have this data set up the same way, which is I have one responder per line and then one variable per column here. And nothing else is included in this data set. And within each cell, there's only one number. Okay, so let me show you an example of what a scatter plot looks like. Okay, remember how you were able to get a mean and a standard deviation and a scatter plot from previous data? Now, you can get a mean of this information here pretty simply in SPSS. This tells you what the mean is. The mean is 64%. So across all of the schools in this data set, not that data set, across all of the schools in this university's data set, the mean graduation rate in 2016 was 64%, 65%. So that's where the mean comes from. It comes from data that look like this, and it always has. Anytime you think about a mean that you've seen represented in lots of the data we've been seeing lately, or lots of the data you've used before, it comes from data sets that look like this. Okay, so that's the first part. The second part is that what I've next done is look at how these two things are related. So how is the overall graduation rate related to the underrepresented minority graduation rate? So right here, oh yeah, 6-year graduation rate. So here is a scatter plot representing the combination or the relation between these two things. And so for each one of these points is representative of an individual university. And so this right here is a university that has a, oh my goodness, 23% graduation rate for their underrepresented minorities students, and they have a about 25% graduation rate for their overall, sort of ignoring race or minority status. So you see that this, one of the things that I think you have learned before coming to this class is that this is a strong positive relationship. As one goes up, the other also goes up. But what I want you to see here, the reason that I'm recording this pre-lecture, is to see that each one of these points represents one school, and that data point is represented here. So one of these is 75 and 67. One of these is 50 and 44, and that represents this university, California State University, Northridge. So as you're thinking about your data, this is what I want you to be thinking about. So if you study who gets fishing licenses in how old they are, I want you to, even though you may not have data that look exactly like this, I want you to think about a scatter plot like this when you're thinking about how your data are set up. And think about whether you would want to know, does the data look like this? Is the age that you are associated with the probability of having a fishing license? Or let's see, the year you were born and the number of records you own, physical copies of records you own. Might be another thing that you might be expect to have a relationship. And so anything that you study, anything that you think about, consider whether you could draw some fake scatter plot and point to each one and say, what is each person? Like, is this a person? Is this a place? Is this which sort of noun is this? And then from there, I think that will help you as you map on how to clean and analyze your data to get it, or clean and prepare your data for this class, so you're able to get it in a situation so that it looks something like this. Because all regression is basically these scatter plots like this. It's taking these scatter plots like this and it's turning them or analyzing them and making them more and more complex across the year. And each time we're sort of looking at how these two things are related to each other. Okay, so that is the basics of what your quantitative data should look like as you get ready to come into this class. You may still have questions about this. Please, please, please email me, let me know, because the last thing I want is to have you feeling overwhelmed or stressed, especially right now, any more stressed than usual. And I really want you to be successful in this class. I teach this class from a mastery learning orientation perspective. I want everybody to leave with the skills to be able to analyze their data. So key to that to me is making sure that you have access to and ability to look at data sets that are interesting and important to you. So get working, have a look at your data sets, draw some fake scatter plots for yourself, think about how things are related,